Welcome back, Perfect Peeps, to Purrfect.dev. Today we're going to talk about Qwik, the HTML first framework. We have Miško Hevery with us. Hello.
Hello, how's it going?
It's going great. Thanks for joining us.
Thank you. It's a pleasure.
If you don't know Miško, I'm saying it right. I'm really bad.
Yeah, no, you're getting it right, Miško.
Awesome.
Yeah.
Miško is the CTO at Builder.io. Miško also created Qwik, which we're going to talk about today, Angular, AngularJS, and is the co-creator of Karma.js. So nothing big, really.
Like, where do you have time in your day?
Yeah, just a few things,
Just a couple things in there. I'm kind of curious. You are the creator of AngularJS, which then later an iteration became Angular. How did you get started with creating AngularJS? What was that like? It was back in what, 2009-ish?
Yeah, 2009.
Yeah, which seems like in web time, like 100 years ago, basically. At that time, frameworks weren't really a thing so much, right?
No, they were not. No,
there was like jQuery, which isn't really a framework per se.
That's right.
So, what led you to create AngularJS?
I built web applications, right? That was kind of my day job. And very quickly, you just kind of get tired of it because it's the same thing. Like if you step back, right, building a web application is a big marshalling problem of getting data from the database to the user and back to the database. That's what the web apps are, right?
Yeah.
And at some point, you're like, I am just tired of talking, setting up a database connection and fetching the data and then showing it to the user. And then the user clicks the delete button and then telling the database to go delete ID, blah, 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 blah. Right? And so Angular actually came out of that particular mindset. Now, there was another piece of mindset that was in it, which was that I had this thing like, can we build I didn't know it was going to be called framework at that point, but can we build something that would allow people who are not experts at coding to be able to do a lot more than what's possible today in HTML? And so the idea was very simple. Like, could we extend the vocabulary of HTML using extra tags in such a way that you could build rudimentary applications with it? So that's where the original idea of Angular came about.
So you were actually working at like Brat Tech. Is that correct at that time?
Well, so Brat Tech was my company on the side.
Yeah, it was your company.
I wasn't really working for it, but yeah, it was my company. By the way, Brat means brother, and so it was supposed to be me and my brother.
Nice. And that was, you weren't working at Google yet, right?
It was on the side of Google. I think the company got started before I joined Google, but yeah, it never really went anywhere. So you can kind of ignore that particular bit. Sure. But I kind of worked on Angular on the side. And then what happened was at Google, I was working on a web application and it was in Qwik. And I was lamenting to my coworkers, like how much pain this is and how much I could do it faster in this toy project that I have on the side. And so they called my bluff and they said, show us. So I went off and kind of ripped, or you have to remember that originally this wasn't meant for be a framework, right? This was really meant for non-developers to be able to do this. And so I would rip random pieces from Angular and then say, oh, this is how you would do rendering, and this is how you would do templates, and this is how, whatever, and kind of glue it together until we had some kind of a system where we could use it to update the UI and build new things.
Sure. And then what was why was there the shift from AngularJS to Angular? What made that kind of occur? Was there just a better way of doing it, or was it a separate team that started another thing?
No, so AngularJS was me being in JavaScript and me not knowing what I'm doing.
Okay.
And there are several properties of AngularJS that are problematic for large teams, mainly the type safety, the globality of it all, and the way variables were bound inside of inherited scopes. And all of those things turned out to be problematic for large teams. And so Angular, which originally was called Angular 2, the idea behind it was, let's clean this up. Like, let's have the same philosophy as AngularJS had, but let's make it for large teams. So proper type system, proper way of declaring things, no global like magic, and so on and so forth. And that kind of was the impetus behind Angular.
Yeah, I think the biggest part, like there's still huge AngularJS fans out there. I actually tried getting into it and it wasn't for me. And then Angular 2
Yeah, so
Angular came along
AngularJS
and
had this nice property that you could just throw a script tag on a page and it like your page would come to life.
Yeah.
Right. And that was really from the original way of thinking about the problem, which was that it was meant for non-developers, right? Like, oh, how could I just extend the vocabulary of HTML? And so the idea was like, just add the script tag, and then your HTML has all this new magic stuff.
Sure.
Right?
Yep.
Turns out when we did Angular, we also were asked to add a Dart, which was a bad choice, but let's not go there. And Dart kind of prevented us from doing this magic. And so Angular doesn't have that magical like throw a script tag and it's all just kind of works. And I miss it. I really miss that particular property. I think it was part of the success of AngularJS. I mean, the other part of the success of AngularJS was that it was the first thing, right? It was a new category defining thing that like nothing like this existed before. Yeah. And so it supported many other things like Vue and React, etc. And these are all improvements on the existing stuff. And so I'm kind of looking at it now as, the framework market is saturated and you don't want to be building yet another framework. So if you're going to do something, like it has to be fundamentally category defining again. Like it has to solve something that the other frameworks cannot touch. Otherwise, it's just not worth the trouble.
And you must have been kind of thinking of this thing for quite a while, and that's why you finally decided,
yes,
hey Google, I need to step away and go do this thing I've been thinking about, right?
That's exactly what happened. So 3 years ago at NGConf, on a keynote, I laid down Qwik. I was like, this is what framework should do. This is how it should work. You have to have all these properties. You have to be able to lazy load this thing. Like I laid it out. There's a keynote that I can find you a link for it if you want. It's on YouTube, and I basically lay out down how Qwik should work. And then, of course, nothing happens for 3 years, right? And at some point, you're like, well, we can keep the status quo, or we could try doing this, right? And so for various reasons, Builder.io actually was an excellent fit because they had a lot of existing customers that had a particular problem to be solved, which is that their e-commerce websites, they really care about the speed of the landing pages, and they can't get there. And Qwik was like, whoa, I know how to get you there. And so this is where we are. So
it's a magical fit between the two.
Yeah.
Perfect. So, and so that's when you were able to become the CTO at Builder then, to kind of take that to the next level.
Yep.
Awesome. Cool. Well, let's dive into Qwik then. Let's talk all about it.
Okay.
So I think with that kind of discussion, it's interesting that we're talking about Qwik, and I'll let you kind of break it down further, but coming from Angular, which is a client-side rendered application, it's a big change and a big shift. Can you tell me about why you are headed down this path in the web?
Yeah. So, I mean, first, let's kind of talk about existing frameworks. And the existing frameworks, they're pretty much all the same in the sense that they're solving a particular problem, which is, rendering the UI. And they're solving it, I would say, in pretty much the similar kind of way. Certainly there are differences in the syntax and how you do it, etc. But the fundamental model is kind of similar between all of them. And the reason I got started with Qwik is because there is a particular problem, and the problem is that we don't know. It's 2021? And we don't know how to make a fast website. And when I use the word fast, I have a particular thing in mind, which is how long does it take for the website to boot up? And this matters, and Google knows that this matters, and they have created this thing called Google Page Speed. And they know that sites that load faster have a better user experience. People like them more. Not only that, they are more likely to buy at that website. And sites that are quick to load are also higher in the Google search ranking as well. So everybody should have incentive to make the best possible, fastest possible websites they can. And if you kind of look at the industry, you will notice that we're not doing so good on Google page speed, right? It turns out that if you look at most e-commerce websites, you'd get like in the low 30s, like teens. Maybe best of the best, like Amazon can get it into like 60s or something like that. But fundamentally, like we kind of suck at it. And my point here is that we suck at it not because like individual companies or engineers are bad at it, but because the way we approach the problem is a bit backwards. And all of the frameworks we have, no matter which one you choose, have the same problem. And this problem I am calling replayable problem. And what I mean by replayable is that you have to do everything twice. You have to replay the work that the server has done. So every framework, or every e-commerce site starts with a server-side rendered HTML, right? And the server-side rendered HTML gets, in order for it to get rendered, the server has to execute your application and do everything that it needs until it produces HTML, and HTML gets sent to the client. Except it's HTML. And HTML is, well, inert, right? It doesn't interact with you. And we all want whiz-bang interactive websites, and HTML cannot deliver. So you need some JavaScript. And that is where the problem starts. Because one of the things that you need to do is you need to figure out where to attach all the listeners, like click listeners and so on and so forth. And how do you do that, right? How do you put all these listeners on the page? Well, you have to download the template. But the template you can't just execute. You have to get the code, the data for the template as well. So you really have to do everything that the server just did. You have to download the data. You have to download the code. You have to execute all of this stuff. You do have to do the merge. And eventually, the framework reconciles the two and produces, registers listeners. And we call this hydration, right? Or reconciliation, or, there's a lot of different terms, but fundamentally it's all the same.
No, does that hold true even like with the Angular framework? I understand like React kind of handles that way, but is that true for every framework that's out there?
Yes, it's true for every single framework that's out there.
Yeah. Is it?
Yeah. Go ahead.
So I would think that React frameworks would do that. Vue frameworks would probably do that. Svelte compiles. So how does Svelte work in that system? That's what I was trying to get a grasp on. Are we talking about diffing the DOM?
So the exact terminology that each of these frameworks uses is different, but the fundamental problem remains, which is that all of these frameworks need to figure out where the listeners go.
Yeah.
And these listeners are not in HTML. They are in source code, in JavaScript, right? And so one way or the other, these frameworks, using whatever fancy terminology they come up with, they have to figure out how to download the JavaScript and execute all the JavaScript, right? And they all have this. And the crux of the problem is that it's proportional to the size of the application. Now, let's get more pedantic here. When I mean the size of the application, not all application is visible at the same time at once, right? Because you have routes and you have different navigations and all that stuff. But for the stuff that's actually visible to the user, all of that code has to get downloaded, and all of it has to get reconciled, or whatever the terminology the framework uses, right? So there is no shortcut. All of these frameworks suffer this particular problem that they have to replay everything that the server did in order to give you an interactive website. And this replaying has two negative consequences, right? One is you have to download a lot more code from JavaScript. And two, you have to execute all this JavaScript. And this is proportional to the complexity of the page that you're displaying. So, right? So the more complicated the page is, the more work that becomes. And it specifically becomes hard because a lot of pages have a lot of static content, but they'll have a menu on the top or a shopping cart or something like that. And the thing is, the way these frameworks work, it doesn't matter that 99% of the content is static. You still have to download all of it, right? Yeah. It's all or nothing proposition. You have to get all of it down. You have to execute all of it. And then you are reconciled, and then you can continue using your application. And so I call this particular property of these frameworks, that these frameworks are replayable, right? And I'm going to make an assertion that all of the current generation frameworks fall into this category. There is not a single framework out there that doesn't have this this property.
That kind of makes sense, right? Yeah. Like if we want any interactivity, like it kind of has to do that the way we write apps today.
Yeah. And so this is where Qwik is different. So Qwik is, in this sense, is replayable. And I'll give a spiel about it, and maybe I'll give you a little demo of what I have in mind.
Sweet.
But when I say replayable, what it means is that, Qwik is resumable. My apologies. Qwik is resumable. What I mean by resumable is that the server can execute code, serialize everything in the form of HTML, send it to the browser, and then the Qwik framework can continue where the server left off. Right? So it has a resumability property, right? So if there's a piece of code that only has to execute in the server, but never on the client, that code would never, ever get downloaded to the client. Now, this gets even better, because one of the things that Qwik can do is it can serialize all of the DOM listeners into HTML directly. And that means that you don't have to do this thing at the beginning where you have to reconcile the world and be like, oh, right, I need to figure out where the listeners are. But in order to figure out where the listeners are, I have to get the templates. In order to get the templates, I have to get the data. And pretty much I have to download the whole pretty application in order to get the page interactive, right? Qwik serializes all this information in HTML. And so Qwik has a very good startup performance, because the startup performance is what we call a quick loader. It's a little tiny bootloader. And the bootloader is 1 kilobyte, less than 1 kilobyte, actually. It's under a kilobyte. And it executes in about 1 millisecond. So it is nothing. It doesn't cost you anything, right?
That's ridiculous.
It's ridiculously tiny, right? All this thing is a global listener in a document that says, if any event happens, so if you click on any button, the button click will bubble the event all the way to the root where the global listener grabs it. And the global listener then goes back into the source of the event and figures out what URL was pointing to the source code, which the button is responsible for, and then goes and downloads that source code and executes just that source code, right? Nothing else. And this is what makes Qwik resumable, is because when the HTML shows up from the server, the application is ready to go. There's nothing to do. There's nothing to re-render, nothing to figure out. It's ready to go, to continue where the server left off and just resume the execution.
Is it static content then?
Yes, so it originally starts as static content because it's HTML. But as you interact with the application, it becomes fully interactive, and we can do all of the operations we want.
So how does that dynamic piece come into play then? If you're pulling all of the static content from the server in the beginning, how do you get that dynamic piece?
Yeah, so in the way to think about it, and this is the kind of little mind bendy, is that the reason why existing frameworks are replayable is because all frameworks have some form of a state, right? And in order for these frameworks to rebuild the state, they have to essentially rebootstrap the application. But Qwik is unique in that Qwik makes sure that all of its state is always in a DOM, in the form of attributes. And therefore, Qwik itself is stateless. And because it's stateless, it can just wake up and continue exactly where it left off, because it doesn't keep track of anything. Everything that it needs is in the DOM itself.
So I think you have a little demo.
I have a little demo. So let me show you a little demo of what I have in mind.
Let's do this.
So we talked about this idea of replayability, but I think it's hard to kind of explain without kind of visuals. So I created this visual thing for what I call a monolith, an island architecture, and I don't really have a good name for the Qwik. I'm calling it the micro islet for now, but the name is still to be debated. So So let me show you what I have in mind. So you have an application, as you can see in kind of a mock browser over here, right? And each of these squares are kind of components. And this is typically how the application is kind of put together. So when this thing shows up, this isn't interactive. There's nothing I can do to this app. It's essentially inert. And so the first thing that the framework has to do, or the browser has to do, is it has to download, right after downloading the HTML, it has to start downloading the application code right here. So the browser downloads the application JavaScript. Now, once the JavaScript shows up, the browser has to execute all of the JavaScript, right? And so the execution of the JavaScript causes some of these components to rehydrate. Again, fancy word that really just means these particular components get their listeners attached to them. Now, at this point, I want to point out something very important, which is that the developer thought that they were going to be clever, and they made particular components lazy loadable through dynamic imports. But notice what happens here. Even though you have these components dynamically lazy loadable, it doesn't help because they're visible, and therefore they have to be rehydrated. And the fact that there is a lazy loading boundary between this parent component and this child component makes no difference. We have to traverse that boundary. We have to go and download the relevant code for it, and we have to go and re-execute and rehydrate the rest of it. So if a component is visible on a page, it doesn't matter how many lazy loaded boundaries you throw in the page. You have to traverse them all. You have to download it all, etc. So as the way to think about it is that the typical application, the bootstrap time is proportional to the complexity of the application that you're looking at, right? The more complicated the application is, the longer the bootstrap time because the more code you have to download, etc. And keep in mind that this is also has a secondary effect that, for example, if one of these components is a shopping cart and it imports the shopping cart, even though you don't need the shopping cart immediately, you're still downloading it, right? Like
sure.
there's all this stuff that just kind of gets pulled in into the whole system. And so people know this is a problem. And so Astro says, we have a solution for you. Instead of having one big monolithic application, you can break up your application in smaller monoliths. We're going to call them islands. They're still monoliths in the sense that they're independent application. In this case, I'm showing them as yellow boxes over here. And what Astro does is says, I am not going to bootstrap this application until you interact with it. So when I go and interact with it, this is the time when Astro goes and downloads the code and makes it interactive. But notice what happened. Now you have multiple apps on a page that all try to be the same app. And so you have a whole new problem that you've created, which is that there is no standard way of doing inter-island communication, right? Components in your framework, and the framework provides a way of communicating between components, and frameworks are really good at this. I mean, that's the bread and butter of what they do. But now that you've broken your app into multiple smaller apps, how exactly are you supposed to communicate? And this gets trickier because oftentimes when I interact with one of the components here, maybe it has to update something in here. So how does this know to go and update a separate component over here? And so on, right? So this is kind of a step in the right direction and definitely is an improvement on a situation, but it doesn't really solve the particular problem that you have. And so what you really want is Qwik. And the way Qwik is different is, as I said, we first download HTML and this tiny little bootstrap code that kind of wakes the whole thing up, and the application is ready to go. There's no more code to execute. It's fully interactive. Everything that you need to do is there. So let's say I go and I interact with this component. Notice what happened. Qwik is able to go and download just the code required to interact with this component and nothing else. So Qwik is really two parts. One is the runtime know-how of knowing how to break the components into pieces, but it's really also a build system that knows how to assemble your application into a lot of small different parts, right? Because if you don't have the build system to do this, the whole thing doesn't work. And people say, well, we already have rollup or Vite or all of these tooling. True, but the real problem is that none of these toolings can do magic, right? If the developer didn't place lazy loaded boundaries in their application, the tooling can't just magically introduce them. And the opposite is also true, which is that if the developer puts the lazy loading boundary in the wrong place, it's not like the tooling can make the boundary disappear. And so the real problem is that in order to really build this kind of application, you need to have a way of taking a complicated application that is written in a monolithic way and somehow break it down. And that is something that is actually, I'm going to argue, next to impossible with the way existing technologies work. And so the whole point of Qwik is that it puts you on a track in a way that makes these breakup seamless and automatic. So what Qwik can do is that when you have a component, you have initialization code, you have rendering code, and you have listeners, right, for interacting with the component. And Qwik can break up all of those things into separate files. Every single one of those things is separate. So if the component needs to be rendered, then we download the rendering code, but we don't download the interaction code. And if you're interacting with the code, but the component isn't being re-rendered, then we don't download the rendering part either. And so it's really intelligent about the way all of this stuff works.
Is this component first then? It seems like it's kind of like an atomic design methodology where you're like breaking it down to that level of the component being the fundamental piece.
Yeah, it is very much broken down into individual pieces as much as you can, right? The idea is that you really want to break this up into as many pieces as possible so that you can do these lazy loading. And I have actually a demo of running an application. But I want to kind of go back over here for a second and talk about these components, because one of the things we saw in the existing frameworks is that the existing frameworks, when they rehydrate, they can't just rehydrate a component. They have to rehydrate the parents and the children of the component, because all of these things are kind of glued together. The magic over here is that I was able to wake up a component, but not its children or its parents. It was completely independent, right? So as I go and interact with the page, different components are brought in, they become hydrated and ready to go without forcing anything else to happen. Now,
how do you deal with that situation that we were talking about before, where up in the like top toolbar area, if that's like a shopping cart or something that you click on, that needs to update a component in the center area there? How is that occurring?
So thank you for a beautiful segue, which is about to talk about it, which is one of the things that Qwik knows how to do is that it understands the relationship of how the data flows through the components. So if I go and interact with one of these components over here, notice what happens to the top component over here. The moment I interact here, the other component gets awoken. And that's because Qwik understands the relationship between these things. And it can deduce, saying like, oh, you changed this, and therefore I also have to go and wake up that other component because you added an item to a shopping cart in here. Like, for example, let's say I click the button over here. You've added an item to a shopping cart, and I had to wake up this guy over here because that's the shopping cart, right?
Yep.
And Qwik understands this, and it can do this. And the most beautiful part of it is that it is done all through HTML. So maybe this is a good segue to talk about reactive frameworks versus non-reactive frameworks. And, the old joke goes that React's not reactive. So let's talk about that for a second. So the only framework that is truly reactive is Svelte. And it is reactive because if you change, hands up, you like Svelte, huh?
Brittany loves Svelte. I work with Svelte, yeah.
Okay, so you know what I'm talking about, right?
Yep.
When you change a piece of data, Svelte knows exactly which bit to re-render. And that's exactly what you want out of a framework. Except that, here is the problematic part, right? So let's before we explain the problematic part, let's talk about the other frameworks. React, Angular, etc. When you change state of the application, the framework itself has no idea what needs to be rendered. The only sane thing to do is to go to the root of the application and say, render. Right? And from the root, the whole thing goes all the way to the children and re-renders the whole page. And maybe you can argue like, oh, but I don't have to go all the way to the root. I can only do a subtree over here. Yeah, there's some minor optimizations, but what you cannot do is you cannot really stop at the children, right?
Yep.
The moment you're rendering, the children are coming for the ride, whether or not. And even if you kind of skip children, saying like, I know this child hasn't changed, you've still already downloaded all of the code for it. So all existing frameworks have this particular problem, is that they don't understand data. And because they don't understand data, the only kind of reasonable rendering strategy is to re-render the whole thing. And that's kind of how most frameworks work. And so Svelte is different. Svelte is reactive, and that's wonderful. Except that in order for Svelte to figure out which component knows about which other component, it has to execute the whole application at least once at the beginning, right? And again, we're like, oh, yes, we're so close, but you missed it. Because the moment you re-render, the moment you execute and in order to execute and download the whole thing, you have to download it and run it. And so, yep, okay, we're done. We're the battle has been lost. And so the thing that's unique about Qwik is that it is reactive on component level. So it's a little less than Svelte. Svelte is, I believe, reactive on the individual binding level. But it does so in a way where the subscription information is in the DOM, so that when the application gets rendered on the server and gets sent to the client, the subscription information is persisted and is available on the client and still continues. I'm going to pause over here, let you ask questions, and then I can show you another demo.
My brain is like stuck in framework land. So I've developed a large amount of like micro front ends with Angular, and like spins up the different frameworks, and you can even create like different areas that are on different versions of Angular, and that all works okay. But I'm like sitting here going, the interoperability to those different things and passing services and data and all that stuff, I'm like, this is a challenge that I kind of am interested in seeing it kind of play out. So maybe your demo will clear that up. I don't know, Brittany, yeah. What do you think?
No, it kind of blows your mind a little bit, because you work in frameworks and you don't think about the underlying mechanics of those frameworks all the time. And Svelte does have that reactivity at like I guess it's still at like the component level at whatever you put it at, but you can have like global state in Svelte too. And I still don't understand how all of it works together and flows together either. But
yeah, but the point of it is that in order for it to work, right, in Svelte has to build up the subscriptions. Right? There's a subscription model saying like, this is the data I'm watching. If this data changes, then like here are the listeners, and they have to get notified. And to build up this tree of like who cares about what, that requires you to download the whole application and execute it at least once. Yeah. After that, you can be smart about it, but like the initial one is kind of what is the problem. So yeah.
How do you take a look, or how do I ask this correctly? Does it make sense when you're loading up Qwik to still do like prefetching so that it doesn't even have to download after you click? Or is that?
Yes. So we do all of that stuff as well, and we can do it using Web Worker and Partytown, and it's this whole separate discussion that we can get into.
I definitely want to talk about Partytown, but I don't know if you want to do your demo piece first.
I do want to see the code too, because I'm very interested in how this looks like templating and syntax wise. So
yeah, so let's do that. So I have this to-do app over here. Standard to-do app that everybody has to build if they're doing a framework. I think
can we zoom it in a little bit? There we go.
Yes. Let's get the font fixed over here. Is that good enough, or should it be bigger?
Yeah, that's perfect.
And yep, and oops, that's the wrong code. This is the right code. And so here is what it kind of looks like. So here's how you declare a component. And I tried really, really hard to make it as succinct as possible, but there are constraints, right? And one of these constraints is that a lot of existing frameworks rely heavily on closures and closing over a related variable that they need. And it turns out that this closures is actually the bit that is completely unserializable, and it's the bit that will kind of mess you up. So Qwik has this extra constraint that it wants to make sure that any of these functions that you pass around don't close over any variables. Or to put it differently, they're only allowed to close over variables that are either exported or imported into a file, but not anything else. So that's one thing. The second thing is, we have this magical thing called Qhook. And the way to think about it, the Qhook is almost like a dynamic import. For various technical reasons, we cannot use import. I can go into it later. But Qhook is essentially the same thing as a dynamic import. And so what this basically means is that wherever you see Qhook, it's a lazy loaded boundary. So that therefore this component shell or the facade or the host can actually load independently from the instructions on how to render the particular component. And I'll show you some more complicated examples in a bit. So in this case, we're just saying we have a to-do app. To render it, just for fun, I'm doing console log so that you can see when different pieces are being rendered. It has props, right? You're saying to-dos, which is your data source for this thing, is getting passed in. And then it says, well, I'm going to do header, main, and footer, and I'm going to pass it into individual parts of the system. And then you can see how header is defined over here. And the header says an initial, I need to create my state. So I will have an empty text. And then on render, obviously I'm going to console this out. I am going to render the to-dos input, and the input is bound to text, as you can see over here. And then if I'll do a key up property, then I'll call this function over here. Like, it's pretty standard stuff, except for this Qhook magic that you see everywhere. Yes, go ahead.
I have two things.
Yeah.
So on mount, so you have some lifecycle methods in there.
Yeah.
And your on : key up looks exactly like Svelte. That is exactly how Svelte does binding for events.
Except Svelte doesn't have this Qhook magic over here.
No, they don't have the Qhook magic. So the whole thing, I thought it looked very similar to JSX in like the JavaScript syntax. Okay. So it is JSX. Okay.
Yeah, I'm trying to not reinvent as much as possible, right? My idea is like, I really would just like to reuse as much as I can out of the existing ecosystem, but I need to solve this specific problem of startup time. So this is actually a good component, and let's kind of dwell into it a little further. And I want you to actually focus on this key up right here, because I noticed that this key up is inside of the input over here. So if I go back to the source and I go to the header, and here's my input right here, notice what happened on the key up. We have a URL that points to some particular location. So the thing that the framework knows how to do, that no other framework knows how to do, is basically how to serialize the listener into DOM in such a way. But there's more to it than that. Not only does the key up get serialized, but also the queue mount and the render method as well. So notice that all of the lifecycle hooks and all the events basically show up in the HTML with URLs. So basically, the quick loader that we talked about earlier, the global listener, knows how to find these and how to download the related code associated with it, and how to execute the code that it finds at that particular location. Does that make sense?
So it's linking back sort of to the initial download in a way?
So this bit here points to this function here. But notice this function is embedded, right? So there requires some tooling that goes and extracts this function. So basically what the Qhook does is it says, go and extract this function into a module scope. And let's just call it new function, it doesn't matter. And then export it like this. You can think of it this way. So there is basically a transformation that happens automatically for you by the build system that does this, so that everything gets basically broken down. So you start with like standard way of writing applications with a little bit, few constraints. And the tooling is allowing you to kind of break all these pieces up into parts. Make sense?
Yeah. I think I'm following so far.
Okay. So now let's watch the magic happen. So one of the things that the framework knows how to do is it knows how to serialize the state. And so the state of the application is serialized right here into the script tag right here. And remember I told you that the whole bootloader is about 1 kilobyte. So that's the only thing that executed so far. Nothing else executed. And the moment I start typing over here, did you notice that the script tag disappeared? That's because the quick loader went into this URL, this qmock module, and it found symbol 9 inside of it. And it it executed the code, and that code over there was basically this function right here. But this Q hook, what it did is did a little bit of kind of a pre-setup work, and it consumed the state of the application, and then distributed the state all across the application. You see where it says Q object over here? This particular thing, all of these IDs point to different objects throughout the system. So let me just refresh this again. And notice that there's a script over here. So you will find that there is this ID called CNK over here, and that's the one pointing to the object over here. And it is also the thing that's being passed into the header inside of to-dos, CNK over here, into the main, CNK over here, and into the footer, into CNK right here, into the to-dos, right? So if you go again here, this is exactly what's happening, right? We are receiving to-dos, and we are passing it into our header, main, and footer.
So are you serializing the entire application into a JSON object and then referencing it?
Yes, and that's what makes it resumable, right? That's how the application, that's how the system can wake up and continue where it left off.
How does this match up? And I don't know if you know Next.js, but they do something similar, right? Where they have the JSON on the preload. Is that?
Yeah, so they have a JSON on the preload, and that's a state of the application. So that when we talked about how the framework is replayable, they need to feed the state into the rendering of the templates. And so that's what the JSON is. So in that sense, it is similar. The difference is we took this to a completely whole new level. Notice that these objects, so first of all, in the case of Next.js, the data that they can serialize must be JSON object.
Yep.
And that means it must be a tree. Because we break everything up into individual parts and we create references, we can do cycles. We can do basically any object you want. I mean, there's still constraints. We can't serialize a stream or a function or any of these things, right? But it's no longer a tree. It could be cycles and so on and so forth. That's one reason why it's different. The second reason is because, remember, as we talked about, that we need a way to know when to wake up objects. Well, this is the magic over here. Notice that this object ID has CNK over here, like this IF, whatever CNK. This is what we received from our parent. But when we are passing it to a child, let's say a header, in the case of a header, notice that the CNK doesn't have an exclamation point in front of it. But in the case of a main, it does. What the exclamation point says to the framework is that the main is actually subscribed to that object, meaning any mutation to that object, main wants to know about. Whereas any mutation to the header doesn't care about. And the reason for it is very simple. If you look at the to-do app, we're passing it to to-dos, to header and main, right? In the case of a header, we're passing to-dos, but notice that the to-dos isn't used anywhere until you actually go and do a key up. And then, adding the item to the to-dos is when we actually need it. But we don't actually need it for rendering. Whereas in the case of a main, we need the to-dos for rendering because we need to, do standard function to filter the items and, generate individual items, right? We need the to-dos to render the list over here. Whereas the header doesn't need the to-dos for rendering. And so this is basically the subscription difference, right? So if this to-do object changes, I need to re-render main and I need to re-render footer, but I don't need to re-render the header. Does that make sense?
Yeah, I think that all makes sense. I'm trying to piece it together with maybe a real world example too. So if I have an API call in there somewhere, would I load up this static data that it knows about on the server at, the server side piece, and then once you key up, it would go fetch again? Is that typically how that would work?
Yeah. So for example, in the case of a to-do, the way to think about it is that on a server, we talk to the database, and the database returned to us the list of items. This is a demo, so it's hard-coded, but
Sure.
That's what the server would do. And then the client doesn't have to do anything with it. It just says, I have this list, and I'm manipulating it. At some point, the client might go back to the server and say, did any of these things change, or I'm deleting one, or whatever, right? And that's for up to application to kind of figure out how that works.
How do you dictate that in Qwik?
You don't. Like, that's outside of the responsibility of Qwik. You just have data, you just have objects. And so to get back to this, actually, let me show you how this thing gets bootstrapped at the beginning. So here's a server, right? I just kind of create the state. Say, like, here's the state. But in server, you would go to some database and go fetch this data, etc. And then we just say QRender, right? We say, go render this, render the body, starting with the to-do app, and I am passing the to-dos into it, right? So to you, it looks just like, some data, nothing special, and it gets passed into a component that gets rendered, and then the whole thing gets dehydrated and sent to the client, right? So let's go back here. So where are we? Okay, so let's type in here. And I wanted to show you something cool. So here's the header, and we know it's a component because it has a Q-render, right? And notice as I'm typing in it, it keeps re-rendering this header component, and nothing but the header. Nothing else gets re-rendered except for the header. But if I say new item and I hit enter, notice that we also had to re-render main, footer, and a specific item that got added. You see that? No other components got woken up or dealt with. And this kind of makes sense, right? Because the main had to be woken up because main iterates over the items. So clearly that has to get woken up. The footer has the number of items over here. Over here it says 4, right? That had to get updated from 3. And of course, the item itself had to get updated as well. Does that make sense? So now let me show you something cool. Let's grab a particular item. So that's this li right here. And we can do something cool here. So we can get a hold of its props. And we work using proxies, but here's our basically object. Let's not go into it for the detail, not to confuse people, but here. So li has, looks like it has an item and it has to-dos. You can see it being serialized in here, right? So what I can do is I can say, give me the item, and I can see that I have the item that says title profit and it's false. And I can also get a hold of the whole to-dos. Those seem to be passed in as well. Now, notice what it says over here is that inside of these Q objects, this is basically our subscription. We care about the 1HR object. So that's the item object. But we don't care, there's no exclamation point, about the CMK object. That's the to-dos object, right? So the system understands that this li has to be re-rendered if the actual item changes, but not anything else. So we can go back to item, and we can, for example, say completed, and if I could spell, okay, it's false. And if I do it true, now notice what happens in the UI. So we're pointing to this profit over here, and look at 4 items in here. If I hit enter, it actually updates. It understands like, oh, I needed to re-render the item because now it becomes strike through and marked out. But footer also has the list of items still left. And so I have to recompute the footer as well and wake it up and re-render. And you can see it over here that the only thing that got recomputed was the item and the footer and nothing else.
It's reactive.
It's reactive, yes.
I think something that might be useful for the listeners or viewers, talking about how that would actually work in React itself. Like, why is Qwik different in this instance than how React would render its tree?
Yeah, so in React, you would call something like set state on some function, right? And the thing that would happen is, especially if you have something like Redux, right? You would update the state of the application, and as a result, the Redux would have to call start re-rendering everything from the root component, and all of the whole tree basically has to get awoken, right? Woken up and re-rendered. Now, of course, React is intelligent and it can skip things, etc. But the end of the day, the whole process is fully synchronous, which means all of the code has to be downloaded on the client before any of these things can happen in React, right? And the magic of Qwik is that it's all lazy and distributed. So we don't download the code for rendering a particular item until we determine that it actually needs to be rendered. We don't download the listener for a particular thing. Like there's an X over here, right? So this X is this button right here, and it has an on-click for deleting the item. There's no need to download the code associated with deleting of the item until you actually click on it. Now, in this case, the amount of code you save is trivial, right? But in real applications, you could have situations where a button adds an item to a shopping cart. And doing so brings in huge amounts of code, right? And so think about something like an Amazon website where you're trying to buy something. There's a menu system on the top, shopping cart on the corner, comments on the bottom, a view of the component, an item you're trying to buy, and then a bunch of thumbnails, and you can hover over the thumbnails, and right? And so when I'm hovering over a thumbnail, why do I download the shopping cart? I don't need it, right? I'm going to interact with the item, and I don't need the menu system. I don't need the comments. I don't need anything else. Why is it being downloaded? Why is it here?
Sure.
So, yeah, I think the beauty of Qwik is that it saves you on that initial build. Like you get the first paint of the DOM is faster. Is that right?
That's right, but it continues throughout the application, right? Because we can just focus on the components that need to be re-rendered.
Instead of waterfalling like React does.
Yeah, instead of waterfalling, yeah.
Yep, okay.
We can save on bandwidth, and this is especially important on mobile, right? If you're on a mobile device on some 3G connection, the less code you download, the better.
Yeah.
Yeah, that makes sense.
And so everybody's talking about like essentially microservices these days, right? If you think about it, like this is microservices on steroids, right? Every single component is an independent entity here, completely broken down, not just by a component, but also by its rendering function, its setup function, its listeners, its click behavioral functions. All of it is just fully decoupled, lazy loaded, and I can do this.
And I heard you say that it's HTML first too. How does it bring in that piece of?
Right. So when I say HTML first, what I mean is that we store all of our information in the HTML, and that's how we know how to do things. Oh, let me explain this better with a demo. Let me do one more thing.
I think I know because of the serializing, and you have it right there in the HTML. Is that what?
Yes. So check this out. How does the system know when to wake up a particular component? So let's say this thing we just did where we did props, item, etc. Right? How do we know that? Well, the system knew that because if you go to an item has an ID, and it is this guy right here. And the way we know is the system can run query selector all, and it can tell me all the objects which contain an exclamation point of this, and I think this goes this way. There you go. So the system runs this query, and it answers the subscription question, right? And it says this guy and this guy, those two components need to be woken up, and you need to do something. And how do we know what to do with it? Well, we go here, and we read the render, etc. So the trick here is to figure out how to take all of the information that the framework needs and put it in the HTML. And this is what I mean by HTML first, right? Because all of this information is in the HTML. And as a result, when the server says, okay, serialize everything, send it to the client can continue exactly where the server left off. It knows where all the objects are. It knows where the subscriptions are. It knows where things get to be downloaded. All the information that you need to just continue where you left off is available for you in HTML. And there's nothing you have to do.
Yeah.
That's really cool. This might be a good time, I think, if you're good with your demo, to pivot over to Partytown and how that will probably help all of this out.
Yeah. So let's talk about Partytown. So our goal is to make sites that are 100 out of 100 on mobile, no matter how complicated your website is, right? And so one thing we discovered is that if you make a blank white page, nothing on it, and put Google Analytics, Google Analytics alone will put you at a precipice of no longer being 100 out of 100. It puts you right at the edge. But people add more things, right? People add analytics, HubSpot, Intercom, and so on and so forth. Right? It's not uncommon for some e-commerce sites to have 20 script tags from other third-party vendors on it. And so we can do amazing things to make the actual website fast, but then people will ruin it all by putting these third-party scripts. And so the idea of PartyTown is, how do we take these third-party scripts and move them to a web worker where they can execute at their own pace without affecting the main thread? And the other thing that PartyTown can do is we can start preloading data for us. So one of the things we can do with Qwik is that when you are developing an application, you have no idea where you need to put the lazy loaded boundaries. And I'm going to argue that you actually never actually know where good places are. And by the time you realize that, oh, I need a lazy loaded boundary, like the app is already huge and it's like a desperate move to like try to break it out somehow, right?
Yeah.
And the problem is that the developer just doesn't know this. Like the developer has to choose where to put lazy loaded boundaries, and they have to actually write code differently, right? Because it's not cheap to put these boundaries in there. And then I actually explained that it actually doesn't make as much difference as you think it does. And because of all of these reasons, the developer just doesn't know how to do this information. Like they fundamentally doesn't have this information. Now, Qwik does something different, right? Qwik puts lazy loaded boundaries everywhere. And as a result, you end up with like, a typical app might end up with like 1,000 different files to download. Now that's bad in the other extreme, right? But the thing we can do is it's relatively easy for Qwik to keep statistics and say like, oh, typical usage of this website, I download all my resources in this particular order. That information can be fed back to the server. And then you can use that information to feed the bundling technology, the bundling system to be like, oh, when you create bundles, experience tells us that a 20 kilobyte bundle is an ideal size. So try to make 20 kilobyte bundles. And oh, by the way, the requests come in this particular order because we have statistical information about how people actually use the website. So make sure you put them in that order inside of these bundles. And because all of these functions are written with this particular constraint that they are only allowed to close over imports or exports and nothing else, the order of which becomes really the bundler has a lot of freedom in what it can do, and it can put them in the correct order. So not only can we create many bundles, or rather bundles in the ideal size, we can also pre-populate them all in the correct order so that the first bundle you download will have the stuff that you are most likely going to need when you're going to interact with the page. And the second bundle will have the next, and so on and so forth, right? And the PartyTown can then load all these bundles eagerly ahead of time, so that by the time you need to go and interact with the page, it's all in the cache and it's ready to go.
That's kind of
and again, I'm going to say none of the existing technologies currently solve this problem. They basically throw their hands up in the air and say, not our problem, somebody else will solve it. Or better yet, they'll say, if there was a sufficiently complicated and intelligent compiler, it could somehow figure this out. And I'm actually going to say, no, such a compiler fundamentally cannot exist, right? If you create a mess out of your source code, there is nothing, no matter how complicated you try, it's impossible to untangle that mess that you've created, right? So the thing that you need is you need guardrails to say, don't create a mess in the first place. And then once you make sure you don't create a mess in the first place, then have a bundling technology that can do this and a runtime technology that can take advantage of it, right? And that's what Qwik is. And I'm going to argue that it's like nothing else out there, right? It is fundamentally a different approach to the whole problem that looks at it holistically, end to end, how to solve this particular thing, rather than like, I'm going to make an awesome rendering technology, or I'm going to make an awesome bundler, or whatever, right? You need to look at it as a unit.
So PartyTown runs the third-party scripts that you would put in. Okay, I was trying to figure out where PartyTown fit in, but I think I got it.
So I went off the topic here. Sorry. So the problem is that these third-party scripts ruin it for us, right? So even if you make this amazing e-commerce website that has 100 out of 100, The moment you start adding third-party scripts, it gets ruined. And so the whole point of Partytown is that move these third-party scripts into the web worker so that they execute over there, and we can have the main thread working as is. And we already have this working for Google Tag Manager, which is one of the most popular third-party scripts. Intercom and HubSpot are pretty much working. I think there's just some minor things over there going on. And there is a few other ones that we also have as well. And so the idea is that we, over time, will get pretty much everything working on the third-party town. And then you can have these amazing websites that are 100 out of 100 on mobile. You navigate to them, and it's instantly there, and you can go and interact with them.
So I think other frameworks are like trying to solve this, maybe not specifically all the way down to the way that Partytown is, but I think Next 11 just introduced Next Script, so it can start to prioritize like what scripts should be loading and how they load and things like that. But
yeah,
it sounds like Partytown's kind of taking it to another level and even getting those off the main thread so the web workers can kind of take care of it while the browser's doing its thing on the main thread itself.
Yeah, so I think you bring up a very good point, which is like the frameworks are in this race of like one-upping each other and saying like, I am faster, more clever about rendering or something like that, right?
I think it definitely all comes back to like Google throwing their page off, right? Like if you're using this, it's not going to be 100 anymore. So I think that's where we're at right now.
Right. And so the situation here is that the picture I want to paint here is that these frameworks are all arguing about who has the most clever way of rendering the page. And then here comes Qwik and says, I just won't render the page. There's nothing for me to do. I'm fast because there's nothing for me to do. Not because I'm clever about how I do it. There's just literally nothing for me to do, right? And this is why it's a completely unfair and it's not on the same level, right? Like if you have to do literally nothing, if you have to execute 1 kilobyte of JavaScript and it takes 1 millisecond for you to execute that, no matter how complicated the HTML is, and then the other frameworks have to download all the code and execute it and figure out where the listeners are and install the listeners and do reconciliation, right? There's just no comparison, right? And no amount of this cleverness that Next.js, as you're pointing out, like, oh, they have we can get smart about in which order we're downloading JavaScript. Like, great, go do that. We don't download JavaScript.
Nice. I see what you're saying.
Do you see how it's just like not the same thing? Like it's just.
I do. I think there's two sides to it. I feel like we're in the middle and then it's going to be the next thing, right? So like Qwik's probably not going to go into like full enterprise mode tomorrow. It's kind of this eventual goal we're all working towards to get it off, to kind of get the main thread down, to get what you're shipping down. Like it's all of these steps that for a long time, we started out with just strictly HTML pages. We've grown up or like grown out, however you want to look at it. We've gotten fatter pages essentially. And then now we're to the point where like, it's too much. We need to trim it down and go back.
Coming back.
Right. So I think it's almost full circle. And a lot of the major frameworks are trying to deal with the now and try to fix the problems that are occurring.
Yeah.
And you're almost looking at that next phase of, okay, now we need to take it to the next level and get these back down to the right size.
And I want to actually point this out in a slightly different way, which is that this isn't a feature, right? Frameworks can up each other up by like, I add this feature, you add that feature. Now I have this feature too, right? This isn't a feature that any existing framework can add to their ecosystem, right? This lazy loading and breaking up of things cannot be done unless you have this constraint that all of the closures that you want to lazy load do not close over random variables, right? All of the existing frameworks do this, right? And therefore, in order for them to add this feature, this capability of this super fast lazy loading, the breaking changes required would be so great that it would be unrecognizable framework.
Sure.
Right? And therefore, none of the existing frameworks can ever add this capability. It is impossible for them to add because it is completely an utter rethink about the way you approach the thing. And it is such a fundamentally low level that it just cannot be added to it.
Do you think, like you kind of mentioned, Svelte is probably the closest? Do you think Svelte has a chance to kind of lean in, or no?
I think it comes down to the fact that there's only all of the existing frameworks rely on sprinkling closures all over the place,
sure,
and closing over convenient variables. And I totally understand from a developer point of view, it is amazingly convenient to just close over things. I get it, but there are consequences, right? And so Qwik says, I'm going to make it as easy for you to make it look like you're closing over stuff, but I'm not going to allow you to do that. And in return, I will give you this amazing capability of lazy loading that you cannot get anywhere else, right? Yeah. So, when I was showing the code before, the function declarations are pretty similar to the way you would declare components today in like React or any of the existing components. They're not that far off, right? This component would be declared very similarly in React or Vue or something of that sort, right? Yeah. But there's just enough differences that make it possible for Qwik to break this component up, whereas it makes it essentially impossible for the other frameworks to break it up.
All right, that was all great to talk through Qwik. Sounds like it's going to be really fun. Now we'll drive into our Purrfect Picks. Let's see here. I think I'm still sharing your screen. Let me add mine. So my first pick today, Web 3.0 is just becoming this thing I cannot avoid. And so I found this great tutorial on how to create an NFT tutorial. And it's all how connecting the Ethereum network and going through it. But I definitely want you to check this out. I'll put the link in the notes for our perfect pick. Miško, do you have a pick for us today as well?
Sure. So it's been a while since I read this book, but I really love this book. And it's called Thinking Fast and Slow. It's by some Nobel laureate winners. But I think it should be really called a human brain operation manual. It basically tells you how your human brain lies to you and how it tricks you into believing things that aren't actually true. And it has like basically lots and lots of experiments that you can do on yourself in terms of like, when I phrase the question in this way, I'm more likely to answer that way. If I phrase it in this other way, then I'm more likely to answer this the other way. My favorite example is, for example, when you have kids and you tell them they're just learning to read and you say, look at this word, but don't read it. And my 4-year-old's like, no problem. I can look at the word and not read it, but you can't do it, right?
Yeah, for sure.
What's the difference? Why is it that he can and you cannot? And the answer, lies in how we process information, etc. All of this stuff is covered in this book. I think it's a wonderful book. It's a really, really thick book. Lots of science in there.
Wowzers.
Mind-opening.
That might have to be a vacation read for me.
It's a thick one.
I'm trying to get through Atomic Habits right now, and the irony is I think the Atomic Habit is trying to set up Atomic Habits for me to get through, so hopefully I'll have it all figured out and get through this book next.
Nice.
Awesome. Well, thank you so much, Miško, for coming on, talking about your history with Angular and laying out kind of Qwik and what seems like should be the future. I hope.
I hope so too.
Awesome. Well, thanks
for
so much.
having me.
Have a good one.
Thanks. Bye.